Let's look at functions, what they are, how to determine if it is a function, how to evaluate functions. Let's get some of that vocabulary. A function is a set of ordered pairs where for every x value there is a unique y value. Remember, an ordered pair has an x value and a y value, and a set could look something like that, where the ordered pairs are contained in braces, and that's where we get the idea of a set. The x values are called the domain and the y values are called the range. We'll talk about this left to right and bottom to top later on in the video. The vertical line test can tell us if a graph is a function or not because it helps us go back to this definition. For every x value there is a unique y value. So what is that vertical line test? It says if a vertical line only crosses the graph once, then the graph is a function. Now, of course, if I draw a vertical line right here, it only touches the graph one point. But is that graph really a function? No. Let's draw another vertical line. Perhaps another vertical line. And you can see this vertical line touches the graph in more than one point. Why is that? Well, let's see. The x value is -3 and the y value looks at +3. However, this also has an x value and it looks like maybe 3.5. So it violates this definition that for every x value there is a unique y value because I had an x value but I had two different y values. So if a vertical line crosses the graph more than once, then this would be not a function. But if I drew vertical lines, multiple vertical lines with this graph, it only crosses the graph, each vertical line only crosses the graph one time. So this is a function because again, for every x value there is a unique y value. If we're given that set of ordered pairs, can we first of all determine whether it's a function? So not from the vertical line test, but just from the definition. For every x value there is a unique y value. So 10 is only listed one time and it only goes with 8. 6 is only listed one time, it only goes with 4. And so yes, this is a function. But what about this set? Well, 3 is listed twice, and so this is not a function because for this x value it's mapped to two different y values. So this is not a function. But we can still give the domain and range of each relation because both I and k are a set of ordered pairs, not necessarily a function, but it is a relation. So my domain, and again you can list these numbers in any order, really doesn't matter. It is the set of x values, and I'm using D for domain, and range would be the set of y values. So we'd have 8, 4, 0, and -4. Here, our domain, we have 3, 8, and 1. There's really no need to list that 3 twice. And our range, 4, -2, 9, and 0. So again, even though this is not a function, it still has a domain and range. So now we're going to look at some properties of graphs. We're going to look at how we find some specific values, how to find the domain and range, and then how to find the intercepts, and that's of course where the graph crosses the axes, the x and the y axis. So let's look at this graph to find these certain values. What is this asking us? It's asking us when x equals -2, what is y? So we go to the x value, come down to the graph, look at the corresponding y value, and it's -3. This one asks us when x is 3, what is y? So it's just asking us the point on the graph when x is 3, y is 5. These next two questions really are asking us that same question but backwards. It's asking us when y equals to negative 4, what does x equal to? So let's look at the graph. When y equals to negative 4, we come across here and the graph here, but if I keep going, here. So it really has 2 points or 2 x values. So this x value is a little bit less than 2, and this looks like right at 4. So how about let's call that maybe 1.7 and then 4. This says when y equals 0, what does x equal? So when y equals to 0, it hits this point, but not that point. It's an open circle. So it says, well, y is really close to y is really close to 0, but not quite there. So we can only count this point at negative 3. Find the x-intercepts. Well, the x-intercepts is where there are points along the x-axis, which is really the same exact question as the one before. When y equals to 0, what is x? And this is the only point. You can have more than one x-intercept on some graphs, but not this particular one. Find the y-intercept. That says when x is equal to 0, what is y? So x is equal to 0 along the y-axis, and that value is negative 2. Some teachers really like you to write these intercepts as ordered pairs to emphasize that when x is negative 3, y is 0, and when x is 0, y is negative 2. Just write those intercepts how you are instructed by your professor. Now we're given different graphs and we're asked to find the domain, the range, any intercepts, and any values that it asks us for. I'm going to go probably backwards from this. Let's just find f of negative 2. Remember, it asks us when x is negative 2, what is y? And it looks like negative 1. What about intercepts? Okay, it crosses the x-axis, so I'm going to say the x-intercept looks like at negative 1, and the y-intercept looks at approximately 4. Now what about that domain and range? Well, we can't list the ordered pairs because there's an infinite. So if you go back to the top of the notes, the domain said to go from left to right. How wide does this graph get? Well, yes, this goes down and down, but it's getting wider, and this goes up and up, but it's getting wider. So we have really all real numbers from negative infinity to positive infinity, and that really should be a review from a previous course. The range is from bottom to top. How low does it go? How tall does it go? And again, there's no jumps or anything, so it's all real numbers. Okay, so I'm going to go to here. When x is negative 1, what is y? Looks like 4. The x-intercept, and it may be more than 1, crosses the x-axis at negative 2. Ooh, about 1.5, about 2.5, and about 4. So that's quite a few x-intercepts, even though it still is a function. Check it with that vertical line test. All right, your y-intercept, let's see, that would be on the y-axis, a little bit less than 3, so how about let's call that about 2.8, close enough. All right, now domain. Domain is left and right. This is the furthest left it goes, and it includes negative 2, so I'm going to put a bracket. And no, it doesn't stop at 4. Can you see that this part is still getting wider and wider? It goes all the way to infinity. The range is how low does it go? Forever, that's negative infinity. And what's the tallest point? at positive 4, and it's included, so we put a bracket. Okay, f of 2, when x is 2, y looks like it's 2. The x-intercept, it only crosses the x-axis at 0. The y-intercept happens to be the same thing. But what about that domain and range? Okay, how left, how right? It goes to -3, but because of that open circle, it doesn't include -3. So we use a parenthesis on that interval notation, and it goes to 2, and it's inclusive. The range is bottom to top. How low does it go? What's the y value? 0. And it looks like it makes it almost all the way up to 3, so we use that parenthesis because it's an open circle. These three don't ask us for a specific function value, but we're still finding the intercepts and the domain and the range, right? So the x-intercepts, let's see, -2. The y-intercept, it's only at +2. That doesn't count. It's an open circle because if it was filled in, that would not be a function. These are functions. The domain, left to right. How left does it go? Well, I see that arrow, so it keeps going to -infinity. And how right does it go? It goes to 3, but it doesn't include 3 because of that open circle. Range, bottom. This arrow is not only going to the left, but it's also going down. And then this is a little bit harder because the range is from bottom to top, but it skips all this. So how are we going to do that? Well, it's going to go to 2 with the bracket, and then we're going to put a union sign. And what y value does that little segment have? It only has a y value of +4. Yes, there are some open circles, but all in here are closed-in points, and that y value is only 4. So that's a little bit tricky, again, because there was that part that was missing. Okay, let's see. X-intercept, does it ever cross that x-axis? Almost, but not quite. So we would say none. Does it cross the y-axis? Yeah, and that looks about -1.5. Domain, how far left does it go? Forever. How far right does it go? Almost 2. Range, this goes down and left. And remember, how tall does it go? Almost to 0. Because that open circle, we don't include 0. I really encourage you to try the next one before I do it. So you might want to pause the video, and when you're ready, start the video again. Okay, x-intercepts, because we do have 2 of them, at -4 and 0. The y-intercept, only at 0. The domain, how far left, how far right. From -4 to +1. And the range, how low, how high. I'm going to call that about -2.5. It's a guess, but it's close enough, to 2. That would be inclusive, so that's why we need to use those brackets.